Good morning, all of you. In this session, I am going to explain about these two problems. I will explain how to convert a given diagram into free body diagram. Okay? Before going to the problems, first of all, you have to know the fundamentals about reaction forces. So this is a cylinder or sphere of a self-weight W. Okay, this is a horizontal support. How to convert this diagram into free body diagram? First of all, you have to convert this self-weight W into vertical force. Self-weight always acts vertically downwards. Okay, this is the action. And here you can observe this is a support, horizontal support. And there is a contact between the horizontal support and this cylindrical surface. Okay. At point of contact, you have to consider a reaction force. Okay. Here the support is horizontal, so you have to consider a vertical reaction. Reaction force always makes an angle 90 degrees with respect to support. Okay. So reaction force always makes an angle 90 degrees with respect to support. Okay, it is very important. So this is the free body diagram for this condition. Okay. For horizontal supports, you have to consider vertical reaction. Okay. In similar way, this is a vertical support. Okay. So here this is a block. There is a contact between the vertical wall and the block. Okay. In this case also, you have to consider a vertical force, vertical downward force for self-weight. Self-weight always acts vertical downwards. And here there is a contact between the block and vertical wall. Here the support is vertical, so you have to consider a horizontal reaction force. Reaction force always makes an angle 90 degrees with respect to the support. Okay. So in this case, self-weight always acts vertical downwards. There is no change. And here the support is vertical, so you have to consider a horizontal reaction. Okay. This is second case. In third case, if you are considering a inclined plane, this inclined plane makes angle theta with respect to horizontal. Then how to convert this diagram into free body diagram? In this case also, first of all, you have to consider a inclined plane as this. Okay. Self-weight always acts vertically downwards. There is no change. Okay, vertical. So self-weight always acts vertically downwards. There is no change. Here the support is inclined. So you have to consider normal reaction. Okay. This reaction force makes an angle 90 degrees with respect to this given inclined plane. Okay. Reaction force always makes an angle 90 degrees with respect to the support. Okay. So now you have to identify the angle of inclination of the reaction force with respect to vertical or horizontal. In this case, you can observe here the inclined plane makes an angle theta with respect to horizontal. So here also angle is theta. Okay. So this inclined plane makes an angle theta with respect to horizontal. Okay. Now the angle between this reaction force and this horizontal reference line is 90 minus theta. Okay. So here the angle is 90 minus theta. Okay. This reaction force makes an angle 90 minus theta with respect to horizontal. Okay. Or this reaction force also makes an angle theta with respect to vertical axis. Okay. So this is the free body diagram for this case. Now these all are important fundamentals for considering the reaction force at point of contact. Okay. So these are the important sign conversions. For right side action, positive sign. For left side action, negative sign. For upward action, positive sign. For downward action, negative sign. Okay, these all are important sign conversions for determining the unknown forces. Now this is a lamis statement. This statement also very important for determining the unknown forces for three forces. For three forces, you have to use lamis theorem. Let P, Q, and S are the three concurrent and coplanar forces. Okay, P, Q, S. P, Q, S are the three coplanar concurrent forces. Here, alpha is the angle between force Q and P, and beta is the angle between force Q and S. Gamma is the angle between the force S and P. Okay. Now, these are the three concurrent coplanar forces. Okay. From lamis statement, force is directly proportional to the sine of the angle between other two forces. Okay. Here the alpha, beta, gamma are the three given angles. Now we have to apply sine rule for this diagram. From lamis statement, force is directly proportional to sine of the angle between other two forces. So here the force is P. P divided by sine beta, and Q divided by sine gamma, S divided by sine alpha. Okay, force divided by sine of the angle between other two forces. Okay, so here let P is the force and other two forces are Q and S. So the angle between other two forces is beta. So P divided by sine beta. Okay. In similar way, Q divided by sine gamma. S divided by sine alpha. Okay. So this is a lamis equation. So this lamis equation is applicable for three concurrent forces only. Okay. Now this is an example problem. For solving this problem, we have to use the lamis theorem. A ball of weight 120 newtons rests on a right angled groove as shown in figure. If all the surfaces are smooth, then determine the reactions at the points of contact. Okay, this is a given diagram. So a ball of weight W equal 120 newtons rests on a right angled groove. Okay, right angled groove as shown in here. So determine the reaction forces at the point of contacts. Okay, there are two contact points here and here. So there are two contact points. So you have to determine reaction forces at each contact point. First of all, you have to convert this given diagram into forces diagram. How to convert this diagram into free body diagram? Let's consider a given plane, horizontal plane. This is a inclined plane, and this one also inclined plane. So the angle between this inclined plane and horizontal plane is 60 degrees, and the angle between this inclined plane and horizontal plane is 30 degrees. So here already we know that the reaction force always makes an angle 90 degrees with respect to the support. So now this is a sulfate. Sulfate always acts vertically downwards. Now you have to consider a reaction force R1 at the point of contact. Okay, this reaction force makes an angle 90 degrees with respect to this support. And this is a reaction force R2. This reaction force R2 makes an angle 90 degrees with respect to this support. Okay. Reaction force always makes an angle 90 degrees with respect to the supports. Okay, please remember, reaction force always makes an angle 90 degrees with respect to supports. Okay. Now you have to determine the angle of inclination of this force R1 and R2 with respect to horizontal. So let's consider this diagram, this triangle. This triangle is a right angle triangle. So here the angle between this corner is 60 degrees. Okay, the total angle is 180 degrees. So already we know the two corners 30 degrees and 90 degrees. The remaining angle is 180 minus 90 minus 30 equals 60 degrees. Okay, so this is a horizontal support. Now this reaction force R2 makes an angle 60 degrees with respect to horizontal as it is. Okay, opposite corners are equal. Okay, in similar way, Let's consider this right angle triangle. From this right angle triangle, the angle between this corner is 30 degrees. Okay, 90 plus 60 equal 120 degrees. Total angle is 180 degrees. 180 minus 120 equal 30 degrees. Okay, now let's consider a horizontal reference line. Okay, the opposite corners are equal. So here the angle is 30 degrees. Okay, opposite corner is same angle. Now convert this diagram into free body diagram. Let's consider a horizontal and vertical reference axis. Let's consider a vertically downward self weight. Now you have to consider this reaction force R1 and R2 as it is. Sorry. This reaction R2, this one is R1. Okay. So this reaction force R1 makes an angle 30 degrees with respect to horizontal. This reaction force R2 makes an angle 60 degrees with respect to horizontal. Okay. Now you have to apply Lamis theorem for this free body diagram. So here you can observe R1, R2 are the two unknowns and W is a known value. So by applying Lamis equation, you can get the value of R1 and R2. Okay. First of all, you have to consider total angle between two forces. Here the angle is 90 degrees, 90 plus 30, 120 degrees for this corner. Now for this corner, the angle is 90 plus 60, 150 degrees. Okay. Now the remaining angle is 360 degrees minus 150 minus 120 equal to 90 degrees. Okay. Total angle is 360 degrees. Okay. Now you have to apply Lamis theorem. From Lamis theorem, the force is directly proportional to sine of the angle between other two forces. Okay. So R1 divided by sine 150 degrees and 120 newtons divided by sine 90 degrees. R2 divided by sine 120 degrees. Okay. From Lamis theorem, you have to consider this Lamis equation. Okay. Now you have to solve these two equations for determine the value of R1. Okay. Apply cross multiplication. R1 reaction force R1 equal to 60 newtons. Okay. Now you have to consider these two equations for determine the value of R2. Okay. Apply cross multiplication. R2 reaction force R2 equal to 103.92 newtons. Okay. So these are the two unknowns R1 and R2 reaction forces at the point of contact. Okay. This is the final answer for this given problem. Now coming to the another example. Two smooth spheres, each of weight 1000 newtons and radius 20 centimeters, are connected at their centers by string AB. Okay, so AB is a horizontal string, AB of length 45 centimeters, rests upon a horizontal plane. Supporting above them a third cylinder of weight 2000 newtons and radius 25 centimeters as shown in figure. Find the force or tension in the string AB and the pressure produced on the floor at the points of contact. Okay. So this is a given diagram. Okay. First of all, you have to convert this given diagram into a force diagram. Okay. Here AB is a string. Okay. Now here and here there are two contact points between the horizontal support and cylinders A and B. And also there are two contact points between cylinder AC and CB. Okay. So there are four contact points and one string. Okay. Here the length of string AB equal to 45 centimeters and the radius of a bottom cylinder is 20 centimeters, and the radius of a top cylinder is 25 centimeters. So these are the two given cylinders. Okay, first of all, you have to consider self weight of a cylinder A. Okay, self weight always acts vertically downwards. Now there is a contact between this cylinder A and the horizontal plane, so you have to consider a vertical reaction force R1. Okay, so R1 is the reaction force between the horizontal support and the cylinder. Okay, and here T is the tension in the string AB. If you are considering this cylinder A, then you have to consider tension in outside direction. Okay, now let's consider this cylinder B. Okay, here also self weight W equal to 1000. Self weight always acts vertical downwards. And now this is the tension in the string AB. If you are considering this cylinder B, then you have to consider left side tension. Okay, these two forces are equal and both are in opposite direction, equal in magnitude and opposite direction. Okay, so T is the tensile force induced in the string AB. Okay, let's consider this upper cylinder C. Okay, sorry, here the reaction force R2 is vertically upwards. Okay, here the support is horizontal, so you have to consider vertical reaction. Now let's consider this top cylinder C. The self weight of this top cylinder is 2000 newtons, so W equal to 2000 meters vertically downwards. Now there are two contact points here and here, so you have to consider two equal and opposite reaction forces. Okay, here there are two movable surfaces, so you have to consider two reaction forces. Both are equal and opposite direction. Okay, here also there are two movable surfaces, so you have to consider two equal and opposite reaction forces. Okay, from this diagram you can observe theta is the angle between the reaction force R4 and the horizontal support. Here also angle theta with respect to the horizontal plane and reaction force. Okay, so here you can observe there are five unknowns: R1, R2, R3, R4, and T. Okay, tension T. So there are five unknown forces. So you have to determine these five unknown forces. Okay. Just consider this triangle for determine the angle of inclination theta with respect to horizontal. Here from given question, the radius of a bottom cylinder A is 20 centimeters and the radius of a bottom cylinder B is also 20 centimeters and the radius of a top cylinder is R equal to 25 centimeters. Okay, so 45 centimeters is the distance between 2 points or the length of the string AB. Now let's consider this triangle as it is. From this triangle you have to determine the value of theta with respect to horizontal. From given question, the horizontal or length of AB, the line AB is 45 centimeters and the length of the line AC equal to radius of a cylinder A plus radius of a cylinder C. So 20 plus 25, 45 centimeters. 45 centimeters is the length of the line AC. In similar way, the length of BC, line BC equal to radius of a cylinder B plus radius of a cylinder C. That one also 25 plus 20. From this triangle, you can observe this is a isosceles triangle. So from this triangle, you can observe a triangle ACD equal to triangle BCD. Okay. from triangle ACD, cos theta equal to adjacent side divided by hypotenuse. So here the adjacent side is AD divided by hypotenuse is AC. So 22.5 divided by 45. From this equation, the angle theta equal to 60 degrees. Okay. So the angle of inclination with respect to the horizontal is theta equal to 60 degrees. Now for determining the reaction forces, first of all you have to consider top cylinder. Okay, in case one you have to consider this upper cylinder. Now you have to consider this free body diagram of a cylinder C. Okay, here there are three forces. You have to consider cylinder C as it is. Okay, R3, R4 and W equal to 2000. Okay, there are three forces acting on cylinder C. Okay, here theta equal to 60 degrees. Now we have to use Lamis theorem for determining the unknown value R3 and R4. Okay, there are only three concurrent forces. Okay, for three forces you can apply Lamis theorem. First of all, you have to consider these three forces as it is. Now you have to consider angle between two forces. The angle between these two forces is 90 plus theta, and a similar way the angle between these two forces is 90 plus theta. The remaining angle between R3 and R4 is 180 minus 2 theta. Okay. Now you have to apply Lamis theorem for this diagram. R4 divided by sine 90 plus theta, 2000 divided by sine 180 minus 2 theta, R3 divided by sine 90 plus theta. Okay. Now you have to use these two equations for determining the value of R4. Okay. Now apply cross multiplication. R4 equal to 2000 divided by sine 60 into sine 150. Here 90 plus theta equal to 150 degrees, 180 minus 2 theta equal to 60 degrees. Okay. So from this equation, reaction force R4 equal to 1154.7 newtons, 1154.7 newtons. In similar way, you have to consider these two equations for determining the value of R3. Now apply cross multiplication. From this equation, the value of R3 equal to sine 150 into 2000 by sine 60. 180 minus 2 theta equals 60 degrees and 90 plus theta equal to 150 degrees. Okay. From this equation, the value of reaction force R3 equal to 1154.70 newtons. From this condition, you can observe the value of reaction force R3 and R4 both are equal. Okay. Both are equal. That value is 1154.70 newtons. Okay. This is case number 1. Okay. From this case, from top cylinder, we got two reaction forces R3 and R4. Okay. Now consider free body diagram of a bottom cylinder A. Okay. Let's consider this cylinder. Here you can observe there are four forces R1, W, T, tension T, and R4. There are four forces acting on this cylinder A. Okay. So this is a cylinder A. There are four forces. Okay. T, tension T, R4 equal 1154.70 and sulfate 1000 and R1. Okay. For four forces, don't consider Lamis theorem. For three forces only, you have to consider Lamis theorem. Okay. Here there are four forces, so Lamis theorem is not applicable. Okay. Now you have to convert this reaction force R4 into horizontal and vertical components. Okay. So this reaction force R4 lies in first quadrant. So you have to consider horizontal and vertical component. This is a adjacent side, so you have to consider horizontal axis as cos theta. Okay, so R4 cos theta and R4 sin theta. Okay, R4 cos theta is the horizontal component R4 sin theta is the vertical component. Okay. So T is the tension. R1 is the reaction force. 1000 is the self weight. Now here you can observe there are 5 forces. Okay. So here from this case you have to determine the unknown forces R1 and tension T. Already we know the value of R4. From case 1 we got the value of R4 equal 1154.7 newtons. Okay. Here theta equal 60 degrees. Now resolve all the forces along the vertical axis. Okay. There are 3 forces. Okay, acting on vertical axis. So for upward action, you have to consider positive sign. For downward action, you have to consider negative sign. So plus R1 minus W minus R4 sin theta equal 0. Substitute R4 equal 1154.70 and theta equal 60 degrees. W equal to 1000 newtons. Okay. From this equation, you can get the value of reaction force R1. Reaction force R1 equal to 2000 newtons. Okay. Now resolve all the forces along the horizontal axis. There are 2 forces. So for right side force, you have to consider positive sign. For left side direction, you have to consider negative sign. So plus T minus R4 cos theta equal 0. So T equal to R4 cos theta equal to 577.35 newtons. Okay. So this is the tension in the string AB. Okay. From this case 2, we got 2 values R1 and tension T. Okay. Now let's consider free body diagram of a cylinder B. Okay, let's consider a free body diagram of a cylinder B. Here also there are 4 forces R2, W, tension T and R3. Okay, this is the free body diagram of a cylinder B. Now you have to resolve these 4 forces. Before going to answer, first of all you have to convert this reaction force R3 into the horizontal and vertical component. Okay. First of all, you have to resolve all the vertical forces along the vertical y-axis. Okay. For upward action, you have to consider positive sign. For downward action, you have to consider negative sign. Plus R2 minus W minus R3 sin theta equal 0. From this equation, reaction force R2 equal to 2000 newtons. Now we have to resolve all the forces along the horizontal axis. There are 2 horizontal forces. For left side direction, you have to consider minus sign. For right side direction, you have to consider positive sign. Plus T equal to R3 cos theta. Now you have to substitute the value of R3 and theta in this equation. We can get the value of tension T. Already we got tension T. That value and this value are same. Okay, 577.35 meters. So this is a given question. So there are 6 contact points. So 6 unknown forces. So the answers are R1 equal to 2000 meters, R2 also 2000 meters, R3 equal to 1154, R4 also 1154 newtons, and tension T is equal to 577.35. The tension in the string AB is T equal to 577.35 newtons. These 4 are the reaction forces or pressure. Okay. So this is the final answer for this problem. Okay. In next class, I will explain more examples on this type of problems. Okay.